Good morning, everyone. Thank you very much for joining us. And my name is Ammi Feiner with PR. And together with me is Ilan Komarovsky from our presale department. And today's seminar is about thermal cameras. Let's start. Ilan, go ahead.
Can you see my screen? Just to verify.
Yes, we can. Just put it in a presentation mode.
Yeah, I'm trying. Okay, so good day, everyone. Today, as Ami told you, we're going to talk about thermal cameras. We gather some experience from your usage of those cameras, and we would like to present you all of those um, pieces of knowledge in one presentation. And so let's start. So the goal of this presentation is to give you all the knowledge and the ability to choose the right cameras for your projects that will fit different demands of the customer. And the other thing is fine-tune your cameras so you'll have less false alarms and you'll be able to gain maximum events related to the security issues. So let's talk about some different technical aspects related to the camera itself. And I'm going to cover some topics that I'm sure you know all about, but still I need to make sure that we are building some kind of line of thought so it will be clear for you what I'm trying to explain. So first one, you all know what is the lens of the camera, and it has a different field of view. So it all depends on the lens itself. The wider the lens, the wider is the field of view. The bigger, lens, the bigger is field of view. And basically, when we have a conversion to a CCTV domain, you have here some kind of table. So, for example, 2.8 millimeter, which is used frequently in our cameras, is a very wide angle. And it could be varying from 90 degrees up to 102 degrees, depends on different lenses, but this is mainly a conversion between the lens in millimeters to the real angle. So when the customer is asking for different lenses, we're talking about actually the distance from the camera that the camera can zoom into and see a distant object from it. Okay, so this is number one. Next topic is about sensor size. So we have different sensors in the cameras, and it all depends on the different usage and industry. So when we're talking about photography, we're talking about medium format, which is a huge sensor, and it's of course more expensive. When I talk about professional photo, then we're talking about full frame sensor, which is the size. And we were talking about CCTV sensors. So we're talking about half of inch or third of inch. This is more or less what is used in CCTV domain industry. Now, and the last topic that you already, of course, know while you're distributing cameras is about resolution. So, bigger resolution, the better information you're getting about small objects. And this is the ability to get investigation of different events by getting the information inside the frame. So why did I talk about all of those topics? This is like a mix of all those different topics into one a specific term which is used in CCTV domain, which is called DORI distances. So DORI distances is basically the ability of human eye to understand what it sees in a picture. And those DORI distances is actually like a short word for detection, observation, recognition, and identification. So basically, it's a cognitive option of a human eye to understand what's going on in the frame. And it's based on how much information we have in the frame about those objects that are moving. So let's dive into it and see exactly what do I mean by those detection, observation, recognition, and identification. So let's break it into those different aspects. So when we're talking about detection, we just see some kind of motion. We don't understand what exactly it is. It requires some checking, so we understand that there are some pixels moving, okay? Next one, we're talking about observing. So we do see some motion, we do understand the behavior of this target, of this person usually, and we understand, for example, that somebody is trying to break into the car by just a few pixels that are enough for us in a cognitive way to understand that we are having a person which is doing some kind of activity. Next one is recognize, is when we do understand by the enough information in the frame that there is a human, and by his moving and his clothes, we do understand who is the person. We know this person, but we don't see his face for clear. But we do understand that this is, for example, our neighbor. And the last one is identify, where we have enough information for surely behind any reasonable doubt to understand that this is a face of somebody who we know, like our neighbor. Okay, so this is again, it's a cognitive ability of our human eye and the brain to understand inside the frame what's going on. And this is why we divided the whole industry divided into those four different recognition ranges. Okay, so how do you understand those DORI distances when you're looking at the data sheet of the camera? So this is an example of many manufacturers. So when you're looking at the camera, you see detect, observe, recognize, and identify. And when we're talking about lens, which is varifocal, you will see wide lens and telescope. So it means it's zoomed out. It's like wide angle, and this is zoomed in to see it to the long distance. This is why we see different distances in meters and feet. So we will understand how we'll be able to operate this camera. Now, there is a specific, like a standard in an industry, which means that for every specific real object in real life, there is amount of pixels we'll need to understand and to fit to those four criteria. So this is like a correlation between real physical world to the pixels of the camera. So for us to detect a motion of an object in a detection mode, we'll need at least 25 pixels for a real square meter. And when we are talking about identifying, which is fully understanding and seeing the face of the object, we'll need 10 times more information. It's 250 pixels per square meter. Okay, so this is like a correlation between the real world and the pixels we're getting from the frame in the camera. Now, you would ask me, how do you calculate this DORI distances? How do you understand it? Like, do you really put the camera in some open field and you start checking the distance from different objects? Of course not. The whole industry is working exactly the same way. We simply calculate it from the different aspects of the lens and sensor parameters. So it's like a mixture of horizontal resolution of the sensor, its width, real physical width of the sensor, pixel pitch, and some parameters of the lens. So basically, by calculating all those different parameters, we're getting to those different distances. Now let's talk about the main reason why we are doing this presentation. How do we understand those DORI distances in the thermal camera? We're talking about thermal sensor. Now, what we are trying to show you here is that there is no relation between DORI, and in our case, in Provision-ISR, we are not using O, we are using DRI, just to simplify the understanding. When we are talking about no relation between the AI detection, I mean cross lines and etc., to our human cognitive ability to understand what we see in the frame. So basically, if you actually want to use AI and to get some alarm about some event like human or vehicle, we recommend to look at the identification, this number. So this number is going to be more or less in the safe side when you want to detect a human crossing a line or getting into sterile area. Okay, and I'm going to clarify it in the next slide. Okay, so again, what we see here is not AI detection. It's like our human ability, cognitive ability to understand what's going on in the frame. And if we want our camera to detect a human being or a vehicle, we will need to use this line identification, like the biggest one where we are getting in regular cameras face recognition. Okay, so let's talk about case study. So we have some distributor who were testing our camera, and he was very happy, and he was using a thermal camera, 90 millimeter, and his actual demand was to detect a human being in a distance of 60 meters. Now, this camera, and it's according its data sheet, you can detect human up to 70 meter. So they were very happy with the camera. It gave them no false alarms, but logistically wise, when they started ordering this camera and they needed for the project very fast, those cameras were not available in stock. So they checked, okay, let's try another camera. And they opened a data sheet of the other camera and they looked at the wrong parameter. And this is a main thing you need to know about. So basically, they looked at detection, which is absolutely different parameter. And when they start working with the camera, of course, it gave them a lot of false alarms because actually they needed 60 meters and the real one is 36 meters, the identification. This is why it's crucial to understand what we mean by analytics and what parameter you need to look at if you want to be on a safe side when you're choosing the camera for your projects. Now let's look at all the different cameras Provision-ISR manufacture. So you can see here different resolutions and the size of the sensor. And what I want to highlight here is that we have a new line of thermal cameras, which I was playing with recently, and you're going to see some videos out of it. So we're talking about Thermal 2. It has a much bigger sensor. It has about 6.6 times bigger sensor than other cameras, basic ones. And of course, it gives much more information when we are talking about thermal image. Now let's start talking about fine tuning. How do we fine tune our thermal camera so it will give us less false alarms and we are going to get real alarms about security events? So when we are going to thermal and different analytics, like we have here line crossing and sterile area, etc., what we recommend from our experience is to use more cross lines than the sterile area because of the way the graphics looks like. So it's basically will give you more reliable results when we're talking about a specific graphical way we are matching, we are creating it for detecting this bounding box around those objects. So basically, we recommend when you're playing the camera and you start doing those rules, uh, I would suggest to use a cross line, which is working better and gives you less false alarms when we're talking about security events when we are looking for humans. Next one is a recommendation to use some kind of delay. So we have a minimum event duration, which means that when we have a motion detected by the camera and we need to react only to human, so this gives the camera more time and more frames to analyze. So it will not raise a flag about some moving objects and will not give you some false alarm about, for example, moving cat. So by providing this small delay, you are giving more time for the camera and more information, so it will react to a real security scenario where we are talking about human. Okay. Next one, we suggest to use the blocking areas. So anytime you have false alarms about some events from, I don't know, reflecting wall, so you can use the block area and you can create different block areas up to 4 units, and you will block some areas which are making those issues of false alarms. Okay, so this is another topic, another like a suggestion. And the next one is about minimum targets. So this is very crucial and very usable in those thermal detection projects. We're talking about creating a specific size of the object. So to make sure that we are not getting some kind of cats and other objects that are looking like human and will raise a flag about security event, we suggest to use this draw object size where you can actually create a specific frame around the real human, and then you will be able to understand, a camera will be able to understand what is going to be the minimum width and size and the height of this human anytime he's going to be in a frame in a specific area. Now, what you see here is detection area 1. So basically, we can create 4 different areas, and those 4 different areas will be able to have a different size of those objects. So this is like a fine tuning that you can create, and each one of those zones will be able to have a different size of the object that you're looking for. Again, I would suggest if you're looking for a human being in this specific area, so it will be only for this area and there will be no other areas. So it will be less false alarms and detection only in specific area and for only human, which is big enough to raise a flag about security event. Next one has nothing to do with actually fine-tuning analytics. This is something for you to know that we have an ability inside our thermal camera due to reasons that it's actually basically 2 sensors. We have a thermal one and we have an optical one. In some cases, you might use NVR, which is actually not fitting to all those channels. So, for example, if you have NVR of eight or actually four channels, and then you still need to use those four thermal cameras. So what we have here is image fusion, which means that we will overlay the thermal side by optical side. So we have here a tool that will be give you an ability to overlay the thermal image by the optical image. So you basically are going to get a fused image here. And it will give you some kind of understanding what's going on from both sensors. So basically what it gives you is an ability to save on the channels inside NVR. Because if you are connecting thermal camera, basically you're getting two channels. So it means that for four cameras, you will need NVR of eight channels. Now, by using this fusion ability, you basically need just to connect the thermal side, and then you will be able to see like a mixture between optical and thermal one. Okay, so it's more about saving. Okay, so let's see some examples, and you can see here clearly the thermal 2 image of the thermal camera, and this is what we see from the camera. And we see that this was actually done during a daytime, which is not the best scenario because we have outside 35 Celsius degrees and we have a human being who is more or less in the same temperature. But it's very clear during nighttime when we have a big difference between the temperature of environment and the human itself. So what I'm showing you here is we are inside NVR and we have here two streams that are coming from the thermal camera. I'm switching from optical side to thermal one. And we are getting this image from the thermal camera. And as I already explained you, I can create here different areas and I can create different actually rules. And for every rule, I have a different size object. So it means that if we're talking about like crossing line on a distant area from the camera, we basically can define that it's going to be minimum size for this specific rule. So for every rule, we have ability to set a different sizes of the object here. This is, as I mentioned, the fine tuning. And same can be done, of course, for the vehicle. Now, once we finished configuring it, we can go and search for those events. So we can choose only the thermal side and we can choose for specific date. And once we finish with clarifying which range of time we want, we can clear out all the scheduled recording and motion events. And then we'll be left only with analytic events generated by this camera. So we can click one of the events and we're going to see that camera captured a human being coming in the morning. Now, again, you need to understand this is crucial for you to understand that the environment here is coming close to the temperature of the human being. So when we are talking about a cold environment, like a cold weather and the human being is coming, it's going to be much more contrasting image. Okay, so once we found this event, we can, of course, go to the playback and then we can see the same events in a bit different way. But again, this is nothing new. We're talking about NVR. Inside NVR, when you go to playback area, you will be able to see here different colors and you can understand that those yellow, green, bright colors is basically analytics captured by the cameras, by thermal cameras specifically, because we are in the thermal camera channel. Okay, so anytime I'm touching one of those events where I'm getting actually to this event of humans captured or vehicles captured by the thermal camera. Next topic is the fire detection. So by now we talked about humans and vehicle, but now let's talk about fire. Fire is a bit different story because we are talking about like a very dense and very different temperature area inside the frame. We're basically talking about plasma. And this plasma should be detected by the camera, and it knows that it's much more, much warmer than the environment. Now, for that one, we have in a data sheet different lines. So what you have here is one is for temperature detection distance. We are going to talk about it a bit later in the next slides. And the one that I'm talking about in this specific slide is a fire detection. So you can see that we having here a distance of maximum distance we can capture by a specific camera. And it actually shows you that we can get the fire detected, but it will be maximum up to 30 meters. And the fire size should be at least 10 by 10 centimeters. So theoretically, if we're talking about big fire, like 1 by 1 meter, we can get up to 300 meters. So it's like doubling every time. So this is like very similar to DORI explanation I gave you about how many pixels per square meter. The same logic is coming here. So bigger fire, the bigger distance I can detect it from the camera. Okay, so let's see how it looks like on the side of the camera. So what we see here in fire detection is the interface where you can create some blocked areas. This is very important because in some cases, because of the reflection from different glass or whatever, we can get some false alarms about fire. So you can block it by blocked area to make sure that you're not going to get those false alarms. Another one is fire detection sensitivity, and the very good one is the tool we recently released is basically for understanding how camera sees this fire. So it will give us some kind of bar, and it will show us what it's actually detecting when we're talking about the fire or temperature. So I have this demonstration recorded. This is me trying to play with hot water and see if it's actually going to generate a fire detection alarm. And you see I'm spilling water on the floor and still it's hot, but it's about 90 degrees, 100 degrees from the heat teapot. Now, if you look at the line here below, it's actually didn't move the line too much because it's not a fire. It's not a huge difference between the environment. It's not a plasma like 400 or 500 degrees that we are getting from the fire. Now, once I'm going to start the fire, let's get to the point where I'm starting the fire. You're going to see that there is a jump in the line, which is detecting fire specifically. And this is a fire starts here. And you see immediately there is a jump here in the detection, real time for the fire detection. So this is how fire looks like because the thermal sensor detected that there is a huge difference between the environment and the fire plasma. And of course, as I mentioned, you have fear fire detection sensitivities that you can correlate and play with, so it will be more or less sensitive to this fire detection analytics. Okay, the last topic is about fine-tuning temperature measurement. By now, we talked about security detection, like humans and vehicles, and we talked about fire detection. But let's talk about a bit temperature measurement when we need to detect engine getting too warm in some kind of machine room or whatever. So we can do the same operation from our thermal camera. But before we're getting into it, we need to understand what is emissivity, because this is a very important parameter for us to operate when we're talking about thermal camera. So emissivity is basically it's how good is the reflection from the object back to the sensor. We're talking about infrared radiation that is coming back into the sensor. And there are two numbers you need to understand. Like one is absolutely black body, like absolutely dark color, which is absorbing the whole infrared radiation. And zero is absolutely perfect mirror. So it brings nothing back. So it reflects the whole infrared back into the sensor. So when we're talking about our interface of the thermal camera, you see here there is a temperature measurement. And this is another tool for us to use the thermal camera. So we'll detect some kind of temperature anomalies. And when we are working with this kind of interface, we see here different parameters, and one of them is emissivity. This is usually the number used for environment, like similar to human skin. And we can define for the camera, so it will understand how far it is from the object it's measuring. So there is some distance from the camera to the object, and reflect the temperature, what is the average temperature in the surrounding of this specific environment. So, if we're talking about some kind of table for you to understand what is emissivity values, so you can check it, of course, in the Google, but we have here some examples of what is different numbers, and you do need to use it when you are talking about different environments. So, especially when we are in a server room and we have those glasses that are reflecting back, you need to play with those numbers to get a full correlation between the physical world and actually measure temperature to the what camera sees and measures. So there will be a correlation. So what do we have on our camera side? So when you get into temperature measurement, you can create different graphical options to measure temperature. It could be like a area, like a sterile area. It could be a point. It could be a line. But inside all of those different options and graphical options, you have here those three parameters we talked about: emissivity, distance, and reflectiveness, which is the reflective temperature in surrounding. And then we have here some rules, which means that if there is some kind of anomaly, I would like to react to it. So what kind of rules we provide inside the camera? We have here a big list of different rules, and I would like to talk about those rules specifically. So if there is going to be some deviation from those rules, we have here a value that you can set that if it's going to be deviating like 5 degrees from specific rule, then I want to create an event. And the event is going to be like a reaction to event, could be alarm output on the camera or siren. So this is like a reaction on the camera side. But before we're getting into the reaction, we need to talk about the reason, the problem itself that we detected. And we need just to understand this is a rule and this is a deviation in degrees. So what are those rules? Let's get into it. So let's assume we have a thermal camera looking at some kind of field and we're getting here a fox. So let's assume that we have an environment which is 0 degrees and the fox itself, let's say it's 40 degrees. So when we're talking about two first rules is about a minimum temperature or below minimum temperature. So you can set and detect and you can define how many degrees is going to be the deviation when the camera is going to raise a flag about this event. Same goes about high temperature. So if it's above specific temperature or below specific temperature, you have rules for all of those events. Another one is average. So again, if you have a specific environment or specific project where you need to set that if there is an average and this average is going to be deviating from this number up or down, then I want to react to it. So you have rules to be able to go over or below each one of those different parameters regarding our environment. And again, you need to set this rule, like in any security camera, you need to set which area we want to measure. And inside this area, you will have those 6 rules, but those are not the whole rules. We have another rule. And this rule is about the difference between different temperatures. So let's talk about scenario. We have the parking lot, and we're having the electric cars that are sometime exploding because of lithium batteries. Now the problem is that the whole parking area is getting from the. Hello? I hear some sounds. Ami, if you can mute. So what we have here is a parking lot, and this parking lot and this car are getting hit by the sun. So it comes from 0 up to 30 degrees in the daytime and 0 degrees at night. And what we have here is a lithium battery that suddenly can stop raising its temperature. So, and we have a detection area. So basically, we have like the object itself is getting hit by the sun, and we know that during normal day, it gets up to 60 degrees, the object itself, and the environment is getting up to 30 degrees. So we know some kind of difference between those temperature. We know what is normal, and we know that it's moving all the time because we have a hot temperature during a day and cold temperature during a night. So we can define that there is a temperature difference between those high and low levels. And we can say that if this is different temperature is going to be more or less static, and we know that the maximum distance between the low and high temperature of the environment is 60 degrees, if it's going to go over it, then we want to raise a flag. Same goes about below. Okay, so we have rules for all different scenarios, and you need to use them. But again, it depends on the project. And the last topic for today's explanation is combined alert. So why do we want to use a combined alert, and which device can give you this ability? So basically, we're talking about NVR. In Provision-ISR, there's a unique ability to react to the event only when there are two events happening at the same time. Like, for example, if you not talk about thermal cameras, like open the gate for a house tenant only if he's coming with his vehicle, the license plate is red, and his face is recognized. So, like, two events are happening at the same time, only then you are going to open the gate. So what I'm trying to show you here is that we can do the same logic with a thermal camera. So because we have in a thermal camera two sensors, one is optical and one is thermal, we can set a rule that says inside NVR, when you're going to detect cross line by optical side and both by thermal side, only then generate an event, raise a flag or whatever. So what basically you have here inside general event, you will be able to find combined alert, and then you will be able to use the same camera, which is having basically two streams. One is from optical and one from thermal. And when you have a line crossing event from those two different sides of the camera, then only then you're going to react with whatever you react, push notification, and etc. So this is it. We finish all the theoretical side, and now if you have any questions, I will be happy to answer those.
Ilan, I do have a question.
Please.
I was listening and learning through the process, and thank you for that. Can you
Mhm.
repeat that part of temperature and maybe give another example? Not sure it's fully clear. Let's say we need to install a camera, as you mentioned, in some kind of a monitoring rack mount or engine. So my temperature in the room is quite fixed, and I need to identify rising temperature. What would be my recommended?
You do see my screen, correct?
Yeah.
So first of all, if you're working in um, environment where you have more or less static temperature that is not changing, then you can work with basically a regular temperature detection. So we're talking about like this one. And we're setting a specific area, and you're looking at this machinery room, and you're saying that if it's going to be above a specific temperature, which is a maximum degrees here, let's say above max temperature that you are setting here, then you can react to it. Like an engine is going over specific temperature. What I showed you the last as an example is when we're having an environment which is flexible, it's like fluid. The whole environment is changing. So you're talking about like a difference because the whole parking area is getting heat and the environment is changing and the temperature of the car is changing. So it's not like a machinery room. We're talking about like static temperature and only if engine is or server is going over specific temperature, then I am reacting. This one is more complicated because we're having like a scale. On a scale, we have a temperature which is moving, and we have a minimum and maximum temperature changing during the day. So what we can work is with the difference between those two ranges, like between maximum and minimum. And we know that during a normal day, we have a maximum difference in the temperature, which is 40 or 60 degrees between the vehicle. And suddenly, during hot time in a day, you're getting over 100 degrees. So you are detecting that something is going wrong. Something is going over specific difference that you are getting during normal days. So it could be a symptom to a lithium battery that is getting overheated and might explode. So this is what I'm talking about. So basically, I converted those rules that we're having here to this kind of explanation about what you can actually get and what kind of triggers you can generate based on the deviation from those temperature. I hope I was clear.
Yep, very much. First of all, thank you very much, Ilan. So it's very, very much educational as always. Um,
Thank you.
Thank you very much for joining us. We're going to close the recording and, of course, leave room for questions.